Imagine stepping into the vast emptiness of space with nothing but your skin as armor. It sounds like the plot of a sci-fi thriller, but the reality is far more terrifying and far less cinematic. When astronaut Thomas Pesquet recently floated outside the International Space Station, ISS, his bulky suit wasn't just a fashion statement. It was a life-saving barrier against the universe's most unforgiving threats. So, what exactly happens to the human body in the void? Strap in. This isn't your average beach vacation. A glimpse into the abyss. Let's rewind to March 1965, when Soviet cosmonaut Alexei Leonov made history by becoming the first human to float in space. His mission? To test the limits of human survival. The pressure differential between his suit and the surrounding vacuum turned his body into a puppet of physics, with his fingers and toes drifting out of place. To escape, he had to intentionally depressurize his suit, risking his life to squeeze back into the airlock head first. Those 12 minutes were a brutal lesson in why space is no place for the unprotected. The invisible killer. What happens when you breathe space? Here's where it gets controversial. The vacuum of space isn't just empty. It's a silent, invisible assassin. Without atmospheric pressure, your body becomes a ticking time bomb. Every fluid in your system, from blood to saliva, suddenly boils at room temperature, a process called ebullism. Imagine your cells turning into bubbles and your tissues swelling like a pressure cooker gone rogue. Death arrives in under a minute, but here's the twist. You wouldn't even hear it coming. Sound waves can't travel through a vacuum, so those dramatic space explosions in movies, pure fiction. In reality, you'd suffocate in silence, from Arctic freeze to solar oven. Now picture this. Your left side is frozen solid at minus 150 degrees Celsius, while your right side sizzles at plus 150 degrees Celsius. Welcome to the temperature roller coaster of space. With no atmosphere to regulate heat, your body becomes a literal ice cream sundae in one moment and a charred marshmallow the next. The sunlit side of the ISS glows like a toaster oven, while the shaded side is colder than a Siberian winter. Spacesuits aren't just puffy. They're thermal shields protecting astronauts from becoming either a cosmic popsicle or a solar-powered steak. And this is the part most people miss. The staggering 300 degrees Celsius temperature swing between your body's sides would make even the most advanced thermos blush. The radiation storm and the armor that saves. But wait, there's more. Space isn't just a cold, silent void. It's also a radioactive battlefield. Cosmic rays, high-energy particles zipping through the galaxy at near light speed, bombard your DNA like a hailstorm of death. These particles can cause everything from radiation sickness to long-term cancer risks. Your spacesuit? It's your first line of defense, acting as a mobile bunker against these invisible threats. Yet, even with all this tech, accidents happen. In 2013, astronaut Luca Parmitano nearly drowned during a spacewalk when his helmet filled with water from a cooling system leak. That's why astronauts train for every contingency, because in space, there's no room for error. The bottom line, why suits are non-negotiable. So, can you survive in space without a suit? Only if you're a superhero. For the rest of us, suits are the difference between floating gracefully and becoming a frozen, boiled, irradiated mess. They're not just practical. They're poetic, transforming humans into glowing marshmallows in the dark. And this is the part we want to hear your take on. Is the future of space exploration about creating thinner, lighter suits? Or do we need to rethink the entire concept? Share your thoughts below. Because if we're going to explore the stars, we might as well do it safely.